Okay, so this is our last discussion, that is on RL filters. So far we have mostly designed RC filters and with op-amp, okay, active filters, but we did not use RL filters. The thing is that we can actually design all those basic filters, low pass, high pass filters, using RL circuit, but we don't normally do that. We actually used RC filters. We use RC filters much more often than RL filters. Now, why is that? The first question is, why we don't use RL filters, you know, a lot? The reason is that the RL filters, we need an inductor. Now, the inductor, how actually, for example, you are actually familiar with inductor like this way, but when you actually try to build this kind of inductors, this is like a coil. You have to apply a coil. Now, this actually makes it much more circuit, much more bulky, okay, much more big, heavy, and expensive. Okay, but compared to that, capacitor is much more lightweight and it actually not so much costly, it's cheap. So that is the reason, one of the reason that we don't use actually RL filters that much. You will learn about these kinds of things, that how you actually can make an inductor, how do you create a capacitor in your um, in your later course like semiconductor device, and there will be another course like VLSI, very large scale integration, in your higher order courses like in your fourth year. So then it will actually become very clear how we actually can create an inductor and so on. So but still, let's get some view on RL filters. So for example, our normal circuit was like this way. This was my resistor, okay, and here we had the capacitor, but now we have inductor. Previously we had capacitor and inductor. So when we had capacitor here, this was my input, this portion is my input, and this was my output side. Okay, this was my output side. And previously the output was like for a low pass filter. Okay, uh, if this was a capacitor, but when you are using a inductor, it actually changes. Okay, it is actually a high pass filter, high pass RL filter. Okay, now why is that? Oh, again, we have to look into the transfer function. Okay, and this is my L, so I have this reactance XL. So I have XL is equals to my twice by FL, so opposite to what was the previous scenario. So that actually means when I have high frequency increases, this XL, okay, also increases. Okay, so when I have high frequency side, I have high XL. High XL means the voltage drop here, this branch voltage drop here is equals to my current and my XL, right? IXL. So when you have higher XL, if XL increases, my V output increases, so I have much higher output here. In the opposite way, when I have low frequency, XL actually decreases, becomes close to zero. So when I have something XL close to zero, so my V output becomes almost equals to zero. So when I have low frequency, it actually works like this way. Okay, so this is my and high pass filter. So I hope the concept is clear. It is just opposite to your capacitor RC network. So this is my frequency. Okay, so this way you can actually build all your high pass filter, low pass filter using RL circuit. Okay, so let's take a look on our PSPice. This is my RL circuit, my source, this is my resistor, and this is my inductor. And if we actually take a look at the output, okay, here is my output. So this was my input and this was my output, a high pass filter of first order, a first order high pass filter. So similarly you can design second order filters and so on and so on. You can do those things. Okay, so this is my our discussion on RL filters. I think it is clear. So the last portion, the other thing is that why do we actually use all these filters that we actually discussed now. And these applications will actually when you actually go for your other courses in your gradually as you go for your higher courses, the applications you will automatically see there are different kinds of applications of this kind of filters. Okay, so for some examples, we can actually discuss some of them. So for example, one is your radio tuning. Okay, tuning of radio. Okay, tuning of radio. In your tuning of radio, say we want to tune our radio in a particular frequency band. We want to tune our radio. So if something like this, we want to tune our radio in our particular frequency band, only this band. we don't want this one to pass, we don't want this portion to pass. So this is like my, if you want to pass this way, so this is like my band pass filter, right? So we can actually use a BPF, a band pass filter, when we actually tuning a radio. Achha. Now there is another one, for example, another example is like in music. It is actually widely used in music, something like bass speaker. I am not familiar with those things a lot. Bass speaker, then treble speaker, some requires low frequency and some are high frequency. We can separate them using and these different types of filter, okay, in musical instruments. Okay, for example, there is another one something it is called interference removal. Interference removal. So for example, when you are actually recording a sound system, so there are sometimes a interference of a particular frequency component. So if I have a particular frequency component, say it is in 5 kilohertz, and I want to cut this portion out, so we can actually use design a notch filter, just crop this portion out. We will not allow this frequency, we will allow this portion, and we also allow this portion. I will selectively cut out this portion. So this is my notch filter. We can actually use this, and this is also very widely used. So this is my notch filter. Now other thing is like in AC power supply. Okay, AC power supply, when you are actually creating different types of converter, you have already seen those things in your electronics course. Uh, there are some AC to DC converter. So when you actually convert from AC to DC, there are always some ripples. Okay, when we actually convert our pure AC signal to a DC signal, and there is some ripples like this way. So there is some ripples. So for example, a low pass filter, or say a high pass filter, I have some ripples like this way. Okay, now when you actually design RL filter, so sorry, when you are actually designing using RL circuit, in using RL load, when you actually design like this way, you have the output something like this. Okay, and this is like my ripple, and if we want to reduce these kinds of ripples, we can actually use different types of filters. Okay, so another thing it comes to my mind, that is noise reduction. Okay, noise reduction is another important example. Noise reduction, whenever you actually record something, there is always some noises along with it. We can actually reduce this noise using our different, by selecting different proper filter. We can actually crop a particular amount of noise. Okay, so this is another one is like anti-aliasing. Okay, this is okay, and these applications I think are okay for you. So this is our discussions on filter design. So there is a long discussion, but try to understand the concepts very well, and I hope it is clear.